Hi folks. We already know Lean plus AI is incredible for mathematics and formalization. But Lean is much more than a theorem prover. It provides a widget framework built on React for UX prototyping together with advanced metaprogramming facilities. This combination makes Lean a powerful platform for building interactive tooling for domain-specific languages. In this demo, I'd like to showcase some of these applications. In particular, I've been using Codex lately with great success, but I wanted to present it with a real challenge. So I asked it to build an interactive debugger for a small toy imperative language, which was inspired by Imp from Software Foundations. In the very first prompt, I asked Codex to define the language, formalize an interpreter, and implement an interactive debugger widget on top of it. And yeah, it produced a working debugger user interface in one shot. After a few more minutes of AI assistant refinement, here's how the sample program looks. You have like global variables, function calls, step back, step in. You can follow, you can see the locals, you can see the heap. Is everything you can continue. You can again get back. So this is everybody you will expect. That alone is really remarkable. But then I thought, okay, we need to keep improving the prototype. We need breakpoints. We need to add breakpoints here. We need to add expressions. But so instead of continuing to extend our custom debugger user interface, why not plug it into something that already exists? In particular, VS Code already ships with a custom, with an extensible and powerful debugger interface. So the real question was, can Codex implement a full debug adapter protocol backend in Lean? That's not a small feature. This involves asynchronous messaging, state management, breakpoints, scopes, evaluation requests, and yet with surprisingly little back and forth. You can see by yourself. We got a working DAP adapter for domain-specific language. In my very humble opinion, this is where Lean really shines. Lean's API are high quality, strongly typed, backed by excellent samples. The types guide the implementation. This makes Lean an exceptional target for serious AI-assisted development. And yeah, once the adapter was in place, everything unlocked. Okay, now we got this for free. We can step through the program. We can see the locals, we can see the heap. We can set a breakpoint. Okay, let's restart. We can set a breakpoint. Let's press play. This stops here. We can, for example, we can edit the heap. Let's edit the heap. This isn't, it's not gonna like it, as you well know. We can like go back. Maybe let's go back. Maybe let's fix this error. Let's add maybe we can add a watch. Let's see, for example, scale plus then plus may fail. Okay, I don't know why. Well, the semantics of this is like this, but then you see, it is here. We can step out. And all inside Visual Studio Code native debugger user interface for our own custom domain-specific language. Well, it's time to stop. And yeah, not only the debugger, but the demo. I hope you enjoyed. A bit of metadata. In total, this took about 10 to 12 hours to build. 2 focus coding sessions, and initial prompt. I gave the model freedom, but also I was very explicit about architecture and goals. And yeah, you can check the repository history to see how it evolved, or even better, just go and try it yourself. And yeah, Lean plus Codex is just powerful for proofs. It's a serious, very serious platform for building tooling. I can't imagine the possibilities. As far as I can tell, no other system can do this today. Well, folks, bye-bye.